Hello friends, this is Praveen. Welcome to ITS Workshop. So today we are going to discuss about Hadoop Distributed File System. So what is HDFS? When we start doing Hadoop stuff, so two topics are most important. First is HDFS and second MapReduce applications. So the HDFS is Hadoop Distributed File System, and the idea of HDFS came from Google File System, that was DFS. So sometimes it is also referred as DFS, only Distributed File System. So today's agenda is what is HDFS, HDFS concepts, name node and data node, what are the files in HDFS and how blocks are created, what are the blocks, and how blocks are replicated. So HDFS is a file system designed for storing very large file streaming data access patterns running on cluster of commodity hardware. So as we have already discussed that Hadoop uses commodity hardware, and HDFS is nothing. We are just having a file system, different dedicated file system, which is supposed to handle very large files. So your normal file system cannot handle big files like which are in MBs. Sometimes the file system handled by your normal operating system, that is in KBs. So we definitely, if we are working with large files, big data, then we need a file system, dedicated file system, which can handle the large file system. So in Hadoop, if you are using multi-node Hadoop, then you can find that it combines the disk of all nodes, and it makes it appear as a single disk. So single slash under single root, you'll find your all other different files and directories and path. So it combines the disk from all nodes, and it make them appear like a single disk, and it runs on top of a native file system. So maybe you are using X3, X4 or XFS, so it is built on top of that. So when you perform Hadoop installation, so you just create one directory for data node and name node, and in the directory you are providing the file, you are providing this file system for HDFS. So those directories are created in your local system. So on top of your native file system, on local system, we are creating HDFS, the large file system. And as we know that it is based on Google's file system, GFS. Now using this diagram, we can understand that in Hadoop we have name node. So name node is management node and secondary name node, which is providing help to name node, and different data nodes are there. So data node 1, and there can be n number of data nodes. So we are combining the disk from all data nodes, and we are making them appear as single slash. So under one, it will combine all capacity, and it will make these appear as single slash or single file system. So we can create further directories like user, under user I'm creating 2 directories likewise. Now there are some scenarios for which HDFS is very good and we should use HDFS, and there are some scenarios where some use cases where it is not a good idea for using HDFS. So if you are dealing with very large files that are hundreds of megabytes, gigabytes or terabytes in size, then HDFS is good. So suppose your file is some 800 KBs. So 800 KBs you are not supposed to use HDFS. Like the default block size in HDFS is 128 MB. So if you, even if you are using 2-3 MB file, it is not good idea. So it is good when your files are in hundreds of megabytes or in gigabytes or in terabytes, then using HDFS is good idea. And second advantage is streaming data access. So Hadoop is good in write once and read many times patterns. So in Hadoop, as you know, like generally the very popular use case for Hadoop is data warehousing. So we are just putting some 2 years of data into the Hadoop cluster and we are performing analysis on it. So it's not like we are interacting with the HDFS system continuously and some transactions are happening in HDFS. That is not the case, but we are putting the data at once, so write once, and we are performing analysis. So it means reading many times out of that written data. So the time to read the whole data set is more important than the latency in reading the first record. So we are putting large files and our pattern is write once and read many times. We perform various analysis on it. Then we are using commodity hardware, so it doesn't require some expensive or highly reliable dedicated hardware. Just your common hardwares, like normal commodity hardwares can be used for Hadoop, and that works same with HDFS. So these are the system which Hadoop works well, and there are some things which Hadoop or HDFS is not a good fit. So like low latency data access. So HDFS is not optimized for delivering high throughput of data, like you are interacting data. So as we are putting data in Oracle database or MySQL database, there it is kind of interaction. So if you want, so not good for application that require low latency access to data. Like low latency access means when the response time with for data access is in millisecond. So if like it happens in normal RDBMS system, the response time for data interaction, like reading data, writing data, updating data, that happens in millisecond. But it is not good in case of HDFS. So if we want some similar functionality for Hadoop, then HBase is a good idea. So we'll see HBase, it will come as a different topic. We'll see more details about it. It is good for low latency access, but generally low latency data access is not good for HDFS. And the second thing, if you are dealing with lots of small files, so for lots of small files, it's not good idea for using HDFS, because name node holds file system metadata in memory, so governing the limit to the number of files. So if there are more number of files, then definitely your name node requires more RAM. So there can be like large files, but not like more number of small files. For lots of small files, HDFS is not good. And multiple writers and arbitrary file modification. So no support for multiple writers or for modifications at arbitrary offset in the file. So when you are putting data in HDFS, then we can perform writing operation, but that writing is generally like appending the file. So it's not like good fit for arbitrary read or updating any line of from any file. That's not good fit. So low latency data access and using lots of small files and writing anywhere is not good fit for HDFS. Now the next thing which we need to understand in case of HDFS are various daemons. So two of them are name nodes and data nodes. Name nodes and data nodes you can better understand if you take this analogy of master worker relationship. So like name node is your master, it is managing the stuff, and data nodes are workers. And we'll see about secondary name node. It is not what it names suggests, like it is not backup and it is not providing a standby backup for the name node. It is just helping your name node. So let us focus on name node and data node. Name node is master and data nodes are worker node. So name node is just managing the file system namespace, metadata and file blocks. So name node is like your boss. It is having the information, who is working, which data block is on which node, like that. And it runs on one machine to several machines. So you can configure your name node on one machine and you can configure on several machines also. And if name node gets down, your system, your total Hadoop cluster is down. So you need to be really careful about name node. And data node stores and retrieves data block. So the actual storage of data is happening at data node. So this is just having the namespace of metadata, and on data node we are really storing the data or files, and it reports to name node. So name node are workers, so workers are supposed to report back to their manager, which is name node here, and runs on many machines. So name node can be on one machine, but data node definitely will be on several machines, or using several machines we are supposed to have data node. Now what is secondary name node? So it periodically merges the namespace image with the edit log to prevent the edit log from becoming too large. So we have edit logs, and your secondary name node is kind of providing help to your name node, and it is continuously merging these namespace images with edit log, so that your name node is free for this task and it doesn't have to do it again and again. So this periodic task is done by secondary name node. Then it requires similar hardware as name node machine. So your secondary name node also requires similar hardware what we are using for name node, and it is not used for high availability, not a backup for name node. So this is general misconception, and in interviews also you can find this question, like is it correct that secondary name node is providing high availability or backup for name node? So from name it looks like it is backup, but it is not backup, it is just helping the name node. So we have seen it maintains the file system tree and the metadata for all the files and directories in the tree. Name node, it is maintaining file system, and two things are maintained, like two files are maintained, namespace image and edit logs. It also knows the data nodes on which all the blocks for a given file are located. So it knows the file location on data node, and data node are the real workhorses for the file system. They are storing and retrieves block whenever they are told to. So by clients or the name node. So client is asking to name node, or client is asking to data node, or data node is asking to, or name node is asking to data node. So then they have to report back, they have to provide the particular data block. They report back to the name node periodically with list of blocks that they are storing. So periodically data node have to provide this information to name node that we are storing these many blocks, and so they are just providing the information. Now what are blocks? So whenever you put any file in your system, so that file, generally we are handling large files, so those files are broken into blocks. And what is block? If you know the general term, the minimum amount of data that it can read or write, that is block. So for any file system which can read or write the minimum amount of data, that is block. So in Hadoop case it is 128 MB. So now 128 MB is the minimum block, which is very large. If you consider the Oracle database has got default block size of 4 KB only. So you can see the difference. In generally we are dealing with 4 KB, 8 KB, or like in terms of KBs, but in terms of Hadoop it is 128 MB, that is default. And so whatever file you want to put in HDFS, you can see here in diagram, these are the files. So let us say our file is 700 MB. So that 700 MB file is divided into block. And now let us assume that the block size is 128 MB. So the 700 MB file is divided into this block B1, which is 128 MB, block C, which is 128 MB, block D 128 MB, likewise. So your file is divided into blocks. Now blocks are replicated or blocks are copied for many purposes, like for faster access, for security, for fault tolerance. So replication means we are taking copies of each block. So if your replication factor is 3, it can be 3, it can be 5. During installation or configuration you are setting it. So let us assume the case which is the default replication is 3. So block B is copied thrice. So B1, B2, B3, these are same copies. And now this is the scheme which we generally use. So these are the racks in your data center. Rack 1, rack 2. So rack contains your servers or your node 1, node 2, like that. So the default the general scheme is that first block you can copy on node in first rack, and second block on different node on same rack. So same rack 1 but different node, and third block is put in different rack. So that's the general scheme. So that's how if this node 2 gets down, we can retrieve this block B1 from node 1, and this rack gets down, we can retrieve from B3. So this provides fault tolerance. So even if some node is down, we can retrieve particular block from another location. So that's how we create. So your file is divided into blocks, and then blocks are replicated. Those replicated blocks are put using this scheme on different nodes in racks. So that's how it works. So file smaller than single block doesn't occupy a full block's worth of underlying storage. So this is one point which looks like tricky in Hadoop. Like your block size is 128 MB. So suppose my file is only 1 MB file. So 1 MB file. So now it looks like the block size is 128 MB file. So if I want to put 1 MB file, then it will occupy full space, 1 MB plus 127 remaining MB. But that is not the case with Hadoop. If you are putting 1 MB file or any file which is smaller than your block size, it doesn't occupy full space. This is one important point to remember. Uses replication for providing fault tolerance and availability. Like we have seen in this diagram, how each block is getting replicated, and we are putting the copies of block on different nodes. Now this is the default scheme. First replica on the local rack. So even if you see this diagram, that first replica on local rack, and second replica on the local rack but different machine. So second replica on the local rack but different machine. So this can be first replica, second replica, and third replica on the different rack. so third replica on the different rack. So from this diagram also this concept is clear, that first replica is put on same rack but different machine, second replica same rack different machine, and third replica different rack and obviously different machine. So that's how it works. So HDFS is very useful, very famous, and we use it for storing large files, and we in distributed manner. So even though your nodes are distributed, still it shows as combined one under one root directory. Everything comes under one root directory. And the second thing which it provides, the fault tolerance and availability of your blocks. So you are performing calculation, you are performing various analysis, every time your blocks are available. So that's how it works. So it's very good system, very smart system, and which gives fault tolerance and security to Hadoop. So that's it for today. If you are looking for more details, you can contact us, or you can read from this book, The Definitive Guide from Tom White. And thanks for watching. If you like this video, please click on like button. We'll continue with the Hadoop series, and please subscribe and please share.